We continue with our discussion on the Perl language and its features. If you recall, in our last lecture we were talking about the scalar and the array variables in the Perl, how it can be used. Today we continue with what we are talking about. We look at some of the other facilities or other you can say features that you can have in association with an array. Let us start with sorting. Perl provides a very simple mechanism to sort the elements of the array using the sort keyword. Default sorting method is we can sort the elements lexicographically. Lexicographically means the elements of the array are treated as character strings and they will be sorted in the order of the dictionary, in the dictionary order. Dictionary sorting means lexicographic ordering, okay? And the sort command by default considers that all elements are a string. For example, if you write a number 25, it will be considered as a string 2 and 5, okay? So, some examples: colors equal to say using the quote word command, you define this array as red, blue, green, black. If you write sort call another array equal to sort colors, so the new array sort call will be, this will be sorted black, blue, green, red, right. So, this is the correct order of sorting, lexicographic ordering. But there is a peculiar problem you will see if you try to sort a number array like this. Suppose you had a number array which contained 10, 2, 5, 22, 7, 15, and if you give sort command to sort this array now, what you will find is that you will be getting the sorted list as something like this, which is not what you expect in a numerical sorting. But in lexicographic ordering this is fine, because in dictionary ordering 1 will always come before 2, that is why 10, 15 the first letter is 1, they will come before anything starting with 2, 2, 22, then 5, then 7. Okay. So, the first letter is 1, then 1, then 2, 2, 5, 7, so on. Now, if we want to sort numerically, there is a way out also. Well, we will explain why this happens later, but for the timing let us look at the solution. Take the same array of numbers, same command, but in between you write something more, curly bracket $a less than equal to greater than $b curly bracket closed. This in a sense tells the sort command that sorting has to be done in the numerical order. So, if you give a sorting command like this, you will actually get the sorted list like this, what to expect after sorting. Splice is a function which can selectively take out some elements of the array. Sometimes if you have an array, from the middle you may want to take out or delete or remove some array. Say earlier you had seen using the push pop and shift, this kind of functions, you can access the elements at the head and the tail, but what about the middle? Suppose I want to remove 2 elements from the middle of an array, the splice function can be used to do that. So, there are 3 arguments to this splice function. The first argument is the array on which you want to operate. Second argument is an offset, which is actually an index number of the list constituting the array, at which you are intending to begin splicing or deleting. And the third argument tells you that how many number of elements you want to remove. Let us take an example. Colors red, green, blue, black, say this is the initial array. Then we give a command like this: splice this array colors 1, 2. What this command will do? This command will remove 2 elements starting from 1. 0, 1, one element is green, green and blue. This green and blue, these 2 elements will be removed from the array colors, and if you assign the value to some other array middle, then middle will contain the list of the elements removed, in this case green and blue, right. So, this is what splice does. Now, let us come to a very important feature of Perl. We will see that it really makes our life much easier for doing certain kinds of tasks. This is file handling, because in the context we are just planning to use Perl in the context of developing the server side scripts, CGI scripts. There the handling of file is very important. First, before going into accessing regular files on disk, we first talk about how a Perl program can interact with the user by reading some data value from the keyboard. Now, you may be knowing that many operating systems treat the keyboard as a special file. It is treated as something called standard input. Reading from the keyboard is considered to be equivalent as reading from a file called standard input. Similarly, outputting on the screen is similar to writing some data on the on a special file called standard output. So, these are some well known features and concepts which most operating systems support. So, Perl also does something similar. When it is trying to read from the keyboard, it assumes that as if it is reading from a file standard input using a file handle within angular bracket standard input stdin. Now in Perl, you know, in a language like C, whenever if you open a file, a number or an integer is returned, which is called the file handle. All subsequent operations on the file are carried out using that number. That is called a file pointer. That is actually technically called a file handle. In Perl, a file handle is indicated by enclosing it within angular brackets. Okay. So, for standard input, the default file handle is stdin. Just look at this code segment: print, enter your name, $name equal to within bracket stdin. This stdin appearing on the right hand side simply means that it reads something from the standard input, and whatever you are reading, that goes into the variable $name. This is as simple as that. Print good morning $name, this is interpolation. So, this name will get replaced by the value you have entered. Okay. But there is one thing to be understood here. When you are reading something from a standard input, say take this example, you are reading a name. So, the user will type a name followed by the enter character, the carriage return. Now, whatever goes into the variable you are assigning to, the carriage return also goes along with it. So, here if you run this program, you will see one peculiar thing. Just see this program like this, that if you give this print, what you are expecting? You are expecting that it would print good morning, then the name of the person which was typed in, /n will move the cursor to the next line. Okay. This S is not there, but what you will see here is that it will go to the next line all right, but there will be one additional blank line in between, as if there are two new line characters which has gone in, right. The reason is that the name itself had one new line character at the end, carriage return /n. So, there should be a mechanism to remove the new line character from the values you are reading from the keyboard before you can actually process or compare with some values. So, there is a need to chop off the new line character at the end. There is a function chop which does exactly this. The chop function removes the last character of whatever you have given it as a parameter. It is a string. The string can be a number, it can be a string with some carriage return at the end. The chop function does not check what is there at the end, whatever is the last character it removes blindly. Okay? This is the function of the chop. It removes the last character irrespective of what it is. For this specific case, well, in the early example, if you look at the early example, you are using $name equal to stdin. Here we are doing the same thing, but we are enclosing it within the parameter of function chop. Chop will do the reading, it will chop the last character whatever is read. So, the new line will go and you will be getting whatever you actually want. Now, as I said, for this example it is fine, but for many other examples you may not want that chop delete the last character blindly, because in some cases there can be new line character, in some cases there can be some other special character also, depends on the context from where the data you are giving as a parameter to chop is coming, because this particular example says that you are taking std in and then you are chopping, that is fine. But if the data is coming from somewhere else, it is possible that the carriage return is not there in the end, something else is there or nothing is there. So, there is a version of chop which you can say is a safer version, which does not accidentally delete useful characters. This is called chomp, CHOMP. This is the name of the version of chop where it chops off the last character only if it is a new line. Okay. So, the same program you can write by replacing chop by chomp, and this is a safer version of the program, in the sense that it will only chop the last character if it is a new line, otherwise it will not chop anything. Okay. Fine. Now, let us move on to the regular file operations. Let us see how we can open a file. Now, a file in Perl can be opened by using the open command. And when you open a file, just like when you open a file using any other language like C, the open command returns a file handle. And as the previous example showed, for standard input the file handle was this stdin. Let us take an example here which illustrates file opening. Suppose this is the file we want to open. This is under home, under ISG, and the name of the file is report.txt. This we are defining as a text and we are assigning to a variable fname. The syntax is open xyz name of the file. So, after opening, this handle xyz is returned, while within angular bracket xyz. See, there is a difference between xyz and angular bracket xyz, or between stdin and within angular bracket stdin. See, stdin represents a file or handle, that means it is the standard input. Within angular bracket stdin means the contents of that file, whatever is there. Okay. Similarly, here this xyz represents the file handle, while this within angular bracket xyz, this means the content, that means it is reading from this file here in this while loop. So, while we will go on reading until the end of file is encountered line by line, and it is printing something line number. These are special variables $dot $underscore. This we shall talk about later again. $dot returns the line number you are reading, and $underscore represents a string which is the contents of the present line. Whatever you are reading presently, that is stored in a temporary variable $underscore, and the line number is contained in $dot. Okay. So, if you look at this program here now, it will print all the lines you are reading with a line number $dot. Okay. So, this is the same program with a slightly different, you can say, modification here. Here we have added this thing. This means, see, you are opening this file, fine. After opening, you are returning the handle. But you know, while opening a file, sometimes some errors happen. The file name you are specifying, there is no name with that file, but somehow the file is locked by someone else, you are unable to open. So, there can be an error message that can return in your attempt to open that file, and the error message has to be sent back to the user. Now, this construct in the open command does exactly that. Or die will be activated whenever there is an error message, and whatever there is there in the quote, that will be displayed on the standard error, which is typically the screen. The error in open colon $! Exclamation is again another special variable. As you can see here, $! Exclamation returns the error code or message. As I had said, $dot returns the line number which starts at 1, and $underscore returns the contents of the last match, which is the contents of the last line. So, this example shows how you can just open a file and also handle errors. Next comes reading. Well, after opening the file, how you can read the contents of the file. Now, the last example which you had shown to illustrate open also illustrates reading, because as I said that the angular brackets whenever you are using to enclose a file handle like this XYZ, this angular bracket is actually the line input operator. This means that you use the file handle XYZ to read a line of data, and whatever you are reading, that data will go to the special variable $underscore. Okay. So, let us look at this version of the program. So, again here instead of reading, we are doing writing. The program is very simple, only there is one difference. First, we are defining the output file, the file name. You are opening, but you are using a greater than sign before the file name. Okay. This greater than sign means that you are trying to open the file for output. Okay. So, for writing a file, you should make sure that there is a greater than sign which is put at the beginning of this $out or the name of the file, whatever the name of the file you can also put here directly, no problem. Or die is a standard error message. If there is any problem in write, there will be error message displayed. Now, the construct we shall be talking about for $I, this $1.20 means This is a for loop where the variable I will continue from 1 up to 20, 1, 2, 3, 4, 20. And here we are asking to print xyz $I, hello, the time is scalar local time. Print xyz means here we are printing with the file handle specified. That means you print not on the screen, but on this file. $I, the line number will be displayed, hello, the time is. You also learn that the scalar local time is a built in function in Perl which gives you the time. So, actually what we will get on the file, there will be 20 lines where the time is continuously displayed as the program executes. Okay. So, this is just an example how you can write into a file. Writing to the end of a file or appending is almost identical. The only difference is that instead of the greater than sign, you use double greater than sign. This is the only difference. Double greater than means append. That is all. The rest of the program is identical. Okay. Finally, when you are done with your reading, writing or appending whatever, you will have to close the file. Closing a file you can do using the close command, close xyz, where xyz is the file handle. Very simple. Printing a file is very easy in Perl. This shows an example. Suppose I want to print this particular file, home ISG report text. So, I store it in a variable, I open it, in is the file handle, with the file input operator, this angular bracket, I give this while in. While in means whatever comes in, it gets stored in the default variable $_. Now, $_ is a default variable, this you should remember. Suppose I give a print statement without anything to print, by default it will take $_. Okay. So, you just look at this program. This while in will read the values into the variables $_ one line at a time, and this print statement where you have not specified anything, this print statements will be printing these values of $_ continuously line by line. Finally, when it is done, you close it. So, you see that just printing the contents of a file is very simple to do in Perl. You can do it very easily. And there is something called command line argument. Let us also have a look at this. Perl uses a special array called @argv. @argv actually means the list of arguments which are passed along with the script name on the command line. What does this mean? See, normally when you run a Perl program, it is said that on the command line you type Perl, which is the name of the Perl interpreter, followed by the name of the Perl program. But when we talk about command line arguments, we are saying that when you are running it, in addition you are specifying something on the same line, red, blue, green. This can be some additional parameters. This is a very common thing you do whenever you say, for example, you compile a program, there are so many compiler flags you use as an optional command line arguments or parameters. So, this example shows you how you can have access to the command line parameters when you are giving a command to run a Perl program. Now, this argv is a special array. It says that after the command and the file name, whatever you have after that, red, blue, green, the array argv will contain exactly that, right. So, if you write a short program like this, all these constructs we will see later again, for each within parenthesis @argv. This means that you take all the elements of argv one at a time, and again when you take it one at a time, the default value will be there in $_. you print either simple print or print dollar underscore explicitly reverse n. Because if you had printed only print, then all the things would print in the same line, this new line would not come. If you want to print them one in each line, then explicitly you have to give this dollar underscore followed by new line. So, this small program snippet will print the contents of argv one in each line. Okay. Now, some standard file handles we have already talked about a couple of them. This stdin refers to the standard input, which usually means the keyboard. Stdout is standard output, which usually means the computer screen. This stderr is the standard error. This is used for outputting error messages. By default, this is also the screen. And argv, as I have just mentioned, this represents the command line arguments. It reads the names of the files from the command line and opens them all. See, here there is something to understand. See, suppose I give a command to run a program. After that, I give some command line arguments x, y, z. So, as I said, this x, y, z as a list will go into the argv array, right. Now, there is a difference. The array argv and the file handle argv. See, array argv you represent by @argv and the file handle argv you represent as within angular bracket argv. There is a very distinct difference between these two notations. This array argv in this case will contain simply x, comma y, comma z, the list of elements that you have supplied. Now, when you are accessing argv with this angular brackets, then you are assuming that x, y and z are names of some files. So, this angular argv will start reading from this file itself directly, and if no file is specified and still you are trying to use argv, then by default it will start reading from the standard input. Okay. Now, this is a very commonly used feature, that is why sometimes instead of explicitly using argv, you can use an abbreviation, just the angular brackets with nothing in between. Just a small example to show. Line number equal to 1, while means here you are reading from argv, okay, print line number and print. So, this program will print the contents of the file you are passing as argument. Suppose you are running the program as this, then your array argv will be file1 dot text, and within angular bracket argv means contents of file1 dot text, that will be read one line at a time. Similarly, for the next one, the contents of a dot text, b dot text, c dot text, all will be read one after the other. So, this program will display the contents of all the files you have specified in the command line. So, you can say in Perl you can do such a complex thing in such a simple and easy way. This means actually is the power or beauty of Perl. You can do so many complex things, including string handling, in a very easy and convenient way. Okay. So, before going further into the other constraints and the other interesting things about Perl, let us look at some of the very standard things like the control structures. Just have a quick look at the control structures which Perl supports. There are many control structures which are similar in syntax to those in the language C, and we would mainly be showing them through examples. There are constructs like for each, if, else and some small variations while, do, etc. So, we shall see that what these constructs are. You may be familiar with the names, but how they can be used in Perl, this we shall see. First, we talk about a statement block whose definition is identical to what is there in C. So, a statement block is a sequence of statements which are enclosed in matching pair, curly bracket open and curly bracket close. Just an example, if year double equal to 2000, curly bracket, print, you have entered new millennium, new line. This looks very much like a C program segment, only the syntax of the print is slightly different. Blocks again like C may be nested within other blocks. Okay. Now, when we talk about conditional statements, say if then else, normally if condition then else. So, something we are evaluating, if it is true we are taking some decision, if it is false we are taking some other decision. Now, let us try to understand what is meant by true and what is meant by false. Now, in some language the 0 value is treated as false and any non-zero value is treated as true. Okay. Let us see what is the convention followed in Perl. In Perl, there are 3 things which are considered as false: the value 0, if it is a string, the empty string, if it is an undefined variable, the undef value. Everything else in Perl is considered to be true. Okay. Fine. And let us start with the syntax of the if else statement. The general syntax is if within bracket some test expression within quote, else within quote. So, this is identical to the syntax of C. Some small examples, but there is some small difference, as this example will tell you. The first example, here we are comparing a variable with a string using the comparison operator EQ, whether this is equal to ISG. If it is so, then we are printing a welcome message, else we are printing some other message. The second example, this shows 2 things. First, it shows that we can use if statement without else also, else block is optional. Second thing is, in this case we are comparing a variable with a number. You see here the comparison operator is different. Instead of EQ, we use the C like operator double equal. So, this also tells you that the operator you use for comparisons for these kind of statements differ depending on whether the numbers or the elements you want to compare are numbers or strings. For equality, for example, equality check, for numbers you use double equal, for strings you use EQ. The else if. Else if is a variation you can have along with the if statement. Just a simple program segment I am showing. It starts with a print enter your ID and you are reading some user ID from the keyboard. The user is entering and you are using chomp to cut off the new line. Then you are comparing whether the ID is ISG or BKD or AKM, and accordingly you are welcoming the corresponding person. If $name equals ISG, you are printing welcome Indranil. Else if is a keyword. If it is equal BKD, you are welcoming Bimal. Else if it is equal AKM, we are welcoming Arun. Else you are printing with a sorry message. So, in this way, if then else, it is quite similar to the C syntax, but there is some small difference. This else if must be together, no space in between. Okay. So, these are standard features. While, well, I am not trying to explain the syntax of while, because this is very similar to that in C, but rather we would like to show an example where the context in which such a while statement is typically used in Perl can be illustrated. See, in C you can use while statement to compute the factorial of a number, for example, by multiplying numbers in iterations, but Perl is mainly meant for string manipulation. Let us see how we can use while for string manipulation or some kind of string related operation. Well, this is a simple application where I am just assuming that I have a secret word called India, and I am asking the person who is running the program to guess the secret word. Now, as long as the correct guess is not given, the program continues running in the while loop. Okay. So, let us see. First is that the choice that the user enters is initially set to null, and the secret word is India. There is a while statement, while your choice not equal to secret word. For the first time it will obviously not be equal, because one is null, other than India. Then print enter your guess chomp your choice standard in. So, you are reading the choice from the standard input and you are continuously comparing in the while loop if it is equal or not equal to the secret word. Now, as soon as this while loop condition is false, they are equal, it will come out and you will be printing a message, congratulations Mera Bharat Mahan. Okay? Fine. For syntax is similar to C, but you can use for in a number of different contexts. You can see this example shows the context where the usage is identical to that in C. You use a variable $i, you have initial value, the termination value and the increments, and you can just use the value of $i within the loop. Okay, just a simple example. For each is mentioned as a constant, as a construct which iterates over a list. Suppose colors is an array which is defined as the list red, blue, green. If you give for each variable name within bracket array, this construct means that you will be looping over all the elements of this array. Since there are 3 elements, red, blue and green, so you will be looping 3 times, once for red, once for blue, one for green, and the current value that you are at, this particular variable will be getting that value. First this $name will get red, second time it will get blue, second time it will get green. So, within the loop you are printing color is $name, so the colors will get printed. Now, the thing to note is that although for and for each have been mentioned as 2 separate constructs or commands, but you can use them interchangeably. For you can use here, for each you can use in the previous case, but some of the Perl authors, they have provided some guidelines that you better use for those kind of application where you are counting the number of iterations, like in conventional for loops. You use for each for this kind of list based operations where you are accessing the elements of the list. Okay? Fine. So, let us take an example here. There is an example which counts the number of odd numbers in a list. The first line defines the initial value of the array, defines the array, this at xyz equal to 10, 15, 17, 28, 12, 77, 56. This is the count value which is initialized to 0, so I am counting. for each a scalar array. So, you are reading the numbers, you are storing them in dollar number one at a time. Using the modulus operator, I am checking if it is odd or not. If modulus 2 equal to 1, it means the number is odd. So, I am printing number is odd, dollar number is odd, I am printing the actual number 15, 17, 77, 3 such numbers are there, and I am also incrementing the value of the count. So, after the loop is finished, number of odd numbers is dollar count. Now, if you basically put this inside this loop, then this line will be printed once for every element as it goes on counting. But if you want this number to be printed only at the end, total number 3 you have found, then this parenthesis you will have to give before out here, okay, then the print statement. Okay. Now, for breaking out of a loop, suppose you have a loop, you have some condition, based on the condition you want to come out of the loop. There is a statement called last. If it appears in the body of a loop, will cause Perl to immediately exit the body of the loop, and the condition can be embedded along with the use of last like this, last if I greater than 10 for example. So, you use a conditional along with last, if the condition is true, then you exit the loop. Similarly, you may want to skip the body of a loop. For example, you have a loop, this loop is an iterative loop, this loop will go on, say for example 10 times. For each iteration you are making some check, if some condition is true or true, then you want to skip the remaining statements in the loop and continue with the next iteration, not exit the loop. Okay. So, you have a construct called next here. When executed, the remaining statements in the loop will be skipped and the next iteration will begin. So, the usage of next is also identical, you will have to use it with a conditional, next followed by a condition. Okay. Fine. Now, let us quickly look at the different relational operators that is supported by Perl. As I said, some of the relational operators are identical to that in C. So, in some cases it is different, because as we had seen one example that the operators you use for comparison is different for numbers, is different from strings. In C you can only compare numbers, you cannot compare strings. For strings you have to use the string comparison function, string CMP or something, okay, but here you can. So, the operators are listed in a tabular form here. There are 6 comparison operations: equal, not equal, greater than, less than, greater than or equal, less than or equal. For numbers, these are identical to what is available in C, but for string you use mnemonics EQ, NE, greater than, LT, less than, GE, greater equal, LE, less equal. So, when you are using a comparison operator, the context should be clear to you. Depending on the context, you will be using either one of these, either the ones for the numerics or the ones for the strings. Now, in addition to the operators, you have some logical connectives also. The logical connectives will allow you to define more complex relational expressions. And suppose I can write if A equal to B and B equal to C, then do this. If A equal to 10 and B greater than 5, do this. So, I can combine this and or of a number of smaller, because relational condition to build up a complex condition. So, for this we need something called logical connectives, okay, and logical connectives, there are 3 such. These are defined as follows: if $A and $B are logical expressions. Okay, logical expression means they have values of true or false. Then the following conjunctions are supported by Perl. Well, there are two styles. These are identical, equivalent. The second style is the C style, where you can use double ampersand for AND, double bar for OR, and exclamation for NOT. But this is much more English like and easier to understand, AND, OR, and NOT. So, it is recommended that we use this style in Perl, so that your program becomes easier to read and understand. And as I said, both the above alternatives are equivalent, but the first one is more readable, and so it is recommended that you use the first one in your programs or applications. Now, to summarize, in today's lecture we had looked at a few things. We had looked at some operations on files, we had looked at some of the conditional operators that are supported by Perl, and the relation operators we had a very quick look at it. Now, using these, I think you are now in a position to start writing small Perl programs. Now, I strongly recommend, that means I have given a number of examples in the course of this lecture. You try out these lectures yourself, you run them on your machine by installing Perl as I had mentioned earlier, and you try to find out what is actually coming, what are the variations you can do to the program, and you can play around with. You will learn a lot that way. Well, I am only trying to give you a guideline, what are the things that Perl supports and how they are, but it is up to you to run programs, to write some more programs, play with it, and understands the nitty-gritties of the constructs and the concepts. Now, in the next class, we will be continuing with our quest for newer features of the language Perl. We will see that there are a number of other interesting features in the language. In particular, there is something called regular expressions, which is considered to be one of the most important features of Perl. It is slightly complex, but we will try to look into them and try to understand how to use them. So, we have come to the end of today's lecture, whatever we have to discuss. Let us now move on to the solutions of the questions we had posed last time. Number 1, do you need to compile a Perl program? The answer is no. Perl need not have to be compiled. We had mentioned that Perl works in interpretive mode. You just need a Perl interpreter which can accept the Perl source code directly and can execute the source code statement by statement. You do not need a separate compiler and a compilation step for executing. Second, when you are writing a Perl program for a Unix platform, what do the first line indicate? Now, this we had mentioned at the very beginning when we are talking about the way to run a Perl program. This actually means that this is the path name, that means user bin Perl, path name of the Perl interpreter. This is a very generalized concept. Instead of Perl interpreter, you can give the name of some other program which will start running whenever you run such a file. Why is Perl called a loosely typed language? It is called loosely typed because the data types, the concept of data types is not present, and you are not defining any variable with any data type by default. So, whatever value you are here assigning, a variable takes that particular data type. Okay. A string can be enclosed within single quotes or double quotes. What is the difference? This we have mentioned repeatedly. If a string is within double quotes, then variable interpolation is in effect, and any variable which is included in the string will get expanded by their value. How do you concatenate two strings? With an example, concatenation can be done by the dot operator. We have given an example in the class also. Several scalar variables you can concatenate by putting dot in between. Okay. So, you get a new string as a composition or concatenation of the three. What is the meaning of adding a number to a string? This I had said that adding means you are actually adding the number to the ASCII value of the string. What is the convenient construct to print a number of fixed strings? Well, you can give print a number of times, but this line oriented quoting is a much more convenient approach. This we had mentioned. How do we add a scalar at the beginning of an array? By constructing a list with the scalar to be added at the beginning followed by the array. This, if you assign it to the same array xyz, this 10 will get added at the beginning. How do you concatenate two arrays and form a third array? Simple, form a list with these two arrays and assign it to a third array. How do you reverse an array? Just give reverse of an array and assign it to something else. How do you print the elements of an array? Print within double quote at array name. So, here also if you give within double quote, then this interpolation will be carried out and the contents of the arrays will be displayed. The elements of the array will be displayed. Now, some questions from today's lecture. How to sort the elements of an array in the numerical order? Write a Perl program segment to sort an array in the descending order. What is the difference between the functions chop and chomp? Write a Perl program segment to read a text file input.txt and generate as output another file out.txt where a line number precedes all the lines. How does Perl check if the result of a relational expression is true or false? For comparison, what is the difference between LT and this less than symbol? What is the significance of the file handle argv within angular brackets? How can we exit a loop in Perl based on some condition? So, these are the questions from today's lecture. So, with this we come to the end of today's discussion. Thank you. In this lecture we continue with a discussion on the Perl language. Now, if you recall, we had already discussed the concept of variables, expressions, how the expressions are evaluated in Perl. We talked about arrays and we talked about a few other string manipulation features that are available in Perl. Now, in the present lecture we would first start with looking at a couple of very interesting and important string functions, followed by something which is considered to be one of the most powerful features of Perl, namely regular expressions. Okay. So, we start by looking at some of the very interesting string functions. Well, the first function is called split. Split, as the name implies, is used to split a given string into multiple pieces using a specified delimiter. What this means is that given a string, there are certain delimiters, some defined delimiters, it can be a colon, it can be a space. This particular delimiter is existing in several different points in the string, and the whole string will be cut at the locations of the delimiters, and the pieces that you get after the cutting, it is formed as a list. So, the result of a split is a list of elements. Okay. So, split breaks up a string into multiple pieces and creates a list. Let us take a small illustrative example. Suppose I have a list like this: red, blue, green, white, 255 separated by some character colon. The whole thing is a list. Now, you look at this assignment, we have assigned this string to a variable $_. Well, we could have used any conventional variable names, but we have chosen to use the $_ character. Now, $_ has a particular significance. $_ is some kind of a default variable in Perl. See, suppose you assign it to a variable, say $ABC, then whenever you want to refer to the string, you should mention the name of the string $ABC. But this $_ which is considered to be the default, if you use it in a string, in many operations you will see that it is not required to specify the name of the string. By default it will be considered, or it will be assumed, that the string is. Understand, this kind of a facility gives Perl its power. This is an example of a regular expression. See, within this forward slashes I am writing every, this is a simple example of a regular expression. And this equal to tilde, this is an operator which means you search. You are searching if the string specified in the right hand side is present in the string on the left hand side. So, you can see this is extremely easy to use. As I had mentioned, the text between the forward slashes, this defines the regular expression, and here we are using equal to tilde to check if it is present. Okay, this one. Now, as an alternative we can use exclamation sign tilde, which means the negation of the condition. This means that the pattern is not present in the string. So, in place of equal to tilde, if I write this exclamation tilde, this would mean that if the string every is not present in $_, then print something. Okay. So, whether you want the truth value of the condition checked in the if statement to be whether the string is present or not present, we can use either equal to tilde or exclamation sign tilde. Okay. So, the example that we had seen, that is an example of literal text. Literal text means within forward slashes we are specifying a simple text to be searched for. This is the simplest possible form of regular expression. Some text enclosed in forward slashes you give, and that you can search whether it is present or not. There are something to remember here, that when you are performing the match, okay, all the characters in the string are considered to be significant.